Okay, good morning, everyone. We are now jumping to a new discussion, or basically, this is a continuation of the previous discussion, but then we will also be formally jumping into the discussion on our rocks and rock types. Um, so, in this pre recorded session, you are going to listen maybe for I'm hoping around 30 minutes of pre-recorded lecture, and then after that is you're going to take a short quiz. So let's start from the mineral group. So your mineral group, considering that there are several minerals named, for example, in this case we have over 4,000 minerals that have been given name. So but pasabot they are identified, as well as the composition is also defined. Katong mga names nila like for quartz, SiO2 and others. There are still new ones that are identified each year. Pero out of the 4,000 and counting minerals, few dozens are abundant. So gamay lang nila dito ang daghan in quantity on the Earth's crust, and hence those minerals na abundant on the Earth's crust are named as the rock forming minerals because they tend to be with mga rock samples nimo, sila mismo ang mga building blocks of minerals. Ito gamay ra kay na sila, class, and you will get to know them. And also these rock forming minerals, specifically if you remember in the quiz and in our class, they tend to have a specific gravity of around 2 to 3. Kaya naman tayo mga minerals nga dagko kayo og mga specific gravity, and those are not found in your rocks. Now, some of those minerals also are used in the process of manufacturing sa products, and hence they are aptly named as economic minerals. And examples anake ka ng mga gypsum, talc, halite. Those are just some of the example of economic minerals because basically they are something na ginagamit nato sa atong mga products, ginagamit sa, even some are used in jewelry, so naa sila yung mga economic values. So in terms of distinction of your mineral group, they can only be classified into two broad classification, which are the silicates and the non-silicates. Now for the silicates, these are minerals with a composition of SiO2. So kindly note it down since I can't write. Okay, I had my stylus replaced since it's damaged. Those silicates has SiO2 as their building block. So that is basically quartz in its pure crystalline form, SiO2. Belong na siya sa imo ang silicate. Now, generally, of course, by composition, if you look at the pie graph, you notice that this is actually, or to be very specific, the distribution that you are seeing here is the relative abundance dinhi sa continental crust ni sila, class. As you know from a fact, oxygen ang pinakadaghan sa tong continental crust. It's followed by silicon, and then we have aluminum, and then iron, and then after that is we have sodium, potassium, magnesium, ay calcium pa di ay no, before calcium pa di after iron. But the point that I'm just trying to make is because of the relative abundance of oxygen and silicon, ang imuhang tendency ana niya karon kay unsa man, most of those minerals will tend to have SiO2 as part of their composition. Naagyo na siya ang imong SiO2. And those which has that type of composition tends to exist in greater quantity. Kadaghan man ang imong silicon and oxygen. Also, class, you need to note that from your chemistry that kining silicon, dili na ko ma-highlight, but that silicon there is actually part of the carbon nga group. Diba? So, kung part siya sa carbon group, which is group 14, na siya upat ka valence electron. So, this also adds to the capability of silicon, nga mura po siya carbon ba, o valence electron. So, mas daghan siya nga bonds nga iya ang ma-form kay naman siya upat ka non-bonding nga electron or lone pairs nimo ba upat ka buok. So mauna nga kaya kanya na makaband with other elements. So Hence, that added to the property of silicon nga maugid siya ang basic kaayo nga composition og daghan kay na sa mga minerals nga naa gyud si silicon as the base niya. So, 8 elements, as you are seeing in the picture, made up the vast majority of the rock-forming minerals, and they represent, tawagan ni, kanang 8 elements nimo, they represent more than 98% by weight of the continental crust in terms of the abundance. So, daghan yung guys sila diri sa atong continental crust. And dili ta ma-surprise dayon why we are having many minerals na ang composition nila is really silicon, oxygen, aluminum, and the rest. So, siguro if you are trying to open Vesta and try to look into the elements, makita man ninyo ng elements nga present, dili kita matingala nga kini gyud sila ang mga key players nga makita ninyo dito. So, oxygen and silicon, they, as I've said kanina, are basically the building blocks of your silicates. Sila gina dira, na sila perminti basta mag-istorya gani kag silicate, automatic na si silicon o si oxygen. Silicate minerals, as we knew earlier, contains oxygen and silicon atoms. Now, all silicates has the same fundamental block. Ang fundamental block na to sa silicate, as you are seeing there, is your SiO4. So, that is the silicon oxygen tetrahedron. So, your silicon nga Si4 plus ang iya ang iya ang unsay tawag ani, iya ang oxidation is Si4 plus, 4 plus yung oxidation na ana siya sa tunga, mo na center sa imo ang geometry niya. Now, ang imo ang oxygen, which has an oxidation state of 2 minus, tends to form at the what do we call this, vertices of your polyhedron, or of your tetrahedron to be specific. So, mao na ang iya ang structure. Dili na ko ma-explain no nga anong dako og size ang oxygen, gamay ang silicon nimo, kay kabalo na mga na dapat sa inyo ang basic chemistry sa grade 7 pa lang ta. In some minerals, your tetrahedra are joined into chains, sheets, or multidimensional networks by the sharing of oxygen atoms. And this is something na makita ninyo if you open Vesta and try to experiment with your specific minerals. So, i-click nimo ng polyhedra. Makita nimo dito that the chain is, some of the chains are formed into sheets. Some of the tetrahedra are formed into chains, into sheets, or multidimensional networks. That is why from the symmetry of the lattice, we can deduce in which plane will it cleave. Ang pinakadali kay kanang mga planes, mga sheets nimo. For the case of olivine group, we knew from last time that there is no cleavage. So, walay plane sa iya ang maputol siya smoothly. So, that is also saying that there is no plane of weak bonds sa imo ang olivine group. So, ang iyang structures na siya ay single tetrahedrons connected together. So, that is your olivine. Now, looking at the structure of olivine from the example here, I think we can say that ang iya ang unsa ka ang lattice nga system ani niya. So, more likely kung ato siyang lantawon no, naagi na siya sa rhombohedral gid siguro. So, i-check lang nato unsa ang tinuod nga lattice ni olivine, but I guess it's rhombohedral just from looking at the sample. Now, the next example that we have here is your pyroxene group. In this case, a very specific is augite, and the cleavage is at two planes at 90 degrees. Now, the silicate structures is single chains. So, kung maglantaw ta ni sa Vesta, so try ganin ninyo, i-open siya sa Vesta, pangitaan ni siya sa katong database, kini nga mineral augite, makita nimo ana niya nga ang iya ang structure dito akay connected together nga single chains nga mga SiO4 nimo, or in this case dito siya SiO4, SiO3 nakita nimo dira. But then the point that I'm trying to show to you is that this group contains silicon and oxygen. Nagyud ang silicon and oxygen dito as the base, kay gitawag man nato siya as mga silicate na to nga minerals. Now, amphiboly, although amphiboly is already complicated with all the different atoms, but you still have your silicon and oxygen there, forming as the base of your structure. Now, i-check lang po ninyo again, the cleavage of that is two planes at 60 degrees. So maybe, I don't know, maybe if dili pa kayo klaro ang cleavage sa you cannot yet deduce the cleavage based from the like the 3D illustration, and maybe by next week before we proceed, let's have another activity or maybe in your quiz. So mag-study na lang yun mo kay appeal ko na siya sa quiz, ilabi na dito sa mga hard questions. Mag-determine mo sa plane of weak bonds ug asa mo cleave ang sample based from the lattice structure nga gihatag sa inyo ha. So the rest of these one are some of the examples na probably nakita na nato. But then if you try to look into this yang formula class, like for example for the biotype, complicated kay siya formula no. But you can always see silicon and oxygen there, muscovite Si3O10, potassium feldspar Si3O8, and so on. So your quartz in its pure crystalline form, that is just SiO2. So basically, the very point that I am saying here is that for your silicate minerals, you really have your silicon and oxygen present there, forming as one of the base of the structure nimo dito. Now, for the non-silicate minerals, these are the type of minerals, as we said earlier, that has economic in value. So these are usually used for constructions, for example, just like what you are seeing near here, no, your iron, aluminum. These are some of the example of the non-silicate minerals. They are used to build our automobiles, gypsum for plaster and drywall, for home constructions, copper wire. Of course, we use that in the electricity sector, especially in our wirings at home, and also to connect us to the internet and all the rest of these mga minerals. Now, some of the non-silicate minerals na it has an important value can either be classified into these three classes of minerals. So usually they are just carbonates, CO3 to negative, sulfates to SO4 to negatives, and halides. So ang halides nimo karon, these are part of your what's this? Ito na siya sa imo ang halogens. Kay mga halides forming man to sa mga compounds. Now, for example, in the non-silicate minerals, we have the thick halite bed in Grand Saline, Texas. So ginamay na to na siya as our salt, and even kanang mga salt na gikan sa Himalayan mountains. Those are some of the non-silicate minerals, because salt, as we said, as we knew, no, pasar siya tanan sa classification of a geologist para matawag na to siya as usa ka minerals. So some of the oxides that you are seeing here are magnetite. So kung natay sa hand sample ani, this will tend to exhibit magnetism over magnetic material. And again, the reason nga nung ingon ana si magnetite has something to do with the d orbital again. So if ang color kay d orbital pod, pwede mapasangin lang ng d orbital. For the magnetism, d orbital gihapon nato na class. So you will get to learn that in complex detail when you advance in your studies, maybe in the university. And hematite also, as you are seeing there, this is actually the ore of iron kana imo ang hematite. So ato pa na siyang i-extract by some processes para makakuha gyud ta sa atong pure nga iron gikan ana. So as you can see here, we are having, you are presented with a table of common non-silicate minerals and their uses. So for the carbonates, these are used, or example of this are your calcite and dolomite, the controversial dolomite like few years ago. Ang economic use ana kay ginagamit gid nato na siya sa lime as well as in Portland cement. Mao na siya ang mga raw ingredient na ginagamit nato dira. So that is why even in Iligan kakita ta nang sa taas no na ay murag ka ng lime na to dira sa Holcim ba na siya kanang ilang ginamain. So mao na ginagamit na to. Okay, of course this is used for the construction. For your halides, natay halite, fluorite, sylvite, nasa sila mga uses. For example, si sylvite, ginagamit nato na siya as fertilizer. Okay, KCl man na siya in chemical formula, no? So, potassium, di ba, ang NPK man gyud ang ginagamit sa murag isa ka factor in plants growth. So, sylvite having potassium as part of the structure, mo na ginagamit sab nato in our fertilizers. And we know na in terms of food security, kinahanglan gyud ta nga ma-secure na to ang dako nga growth or yield sa atong crop. So, you really need these non-silicate minerals. Although, relatively, compared to the other minerals, medyo maot-maot yun na sila naong class. Dili siya mga aesthetic, kumbaga, o mga naong kay. They tend to be ilang appearance sometimes, most of their appearance kay mura siya sometimes dull gid yung appearance kanang dili siya unlike the rest of these minerals nga medyo eye-catching kaayo. But these non-silicate minerals, especially kaning mga oxides nimo, kay ginagamit kay dagko kay na sila mga gamit as well as the halides sa atoa. So for the oxides, hematite, magnetite, corundum, and ice. These are, by the way, ice can also be classified as a mineral. I'm hoping, or I don't know if we were able to talk about that, but ice can be considered as a mineral nimo. So your sulfides, so galena, this is just an ore of lead, sphalerite, ore of zinc, pyrite, chalcopyrite, cinnabar. So mga ore man ni sila, di ba? So of course, unlike your halides nga pwede siya sa salt nato, dili na to ni siya dali. For sinato ni kauno, no? Pero gamit kay ni siya sa atong mga construction as we said na mga automobiles, copper kay ginagamit nato ni sa atong mga penny, sa mercury, daghan pa na siya mga applications, zinc kana sila nga mga minerals kay although dili lagi nato o dali di ta maka mo bitaw dili sila dali kay nato magamit sa atong body, di nato sila kaunon kumbaga, pero kini sila nga mga klase nga minerals are used in aiding our lives, especially in the construction sector, electronic sector. So mao ni yung klase nga mga minerals nga atong ikinahanglan. For sulfates, as you can see here, usually ang sulfate ni mono gypsum and anhydrite. So these are used in the plaster. So ang imuhang mga native elements kini sila gold, copper, diamond, mga non-silicate man ni sila of course kay specific yun siya nga mga elements no other than silicon and oxygen. These are used for of course mga aesthetic ang purposes ani. Pero ang copper, kabalo gyud ta na electrical conductivity, sulfur kay sa mga chemicals, imong graphite sa lead sa imong pencil, dry lubricant, kay medyo talky man gud imong kuan, mura siya ang appearance sa imong graphite, mura siya talc ba nga smooth. Ang imong silver, kabalo ta na platinum is used as a catalyst. Now, these minerals I'm not trying to sell this pero naagyo sila mga specific na economic value and hence the non-silicates are often termed as the economic minerals. Now for the gemstones, as you can see here, we have Australian sapphires depicting variations in cut and color. So these are all sapphires. It will not come as a surprise sa inyo dapat nga nganong lain-lain siya color. One is yellow from the left, the other is blue, and the other is from orange. So hopefully just by looking at the color, you can now somehow predict na ay okay, posible kayo or even if you are not sure, but at least na makaingon yun mga ay posible nganong na yellow na siya kay ang nipuli ana niya kay titanium ang sulod. Alang anong ni blue na siya kay basig na pulihan siya og kuan copper, diba blue violet man ang copper, blue to violet. Lang anong ni orange man na siya. So, possibly mauni siyang element ang nipuli sa iyong color center. But then again, they are all sapphires gihapon. Nalay variation sa color because of the thing na na-learn na to nga ang color di na siya masaligan kay mapulihan na nag-atom ang color center, mabag-o na gyud na siya. Matangtangan na siya electron, pwede gyud nga mabag-o gyud na siya. Okay, so kana siya nga mga butang. And then sapphire is just a variety of the mineral corundum. So kaning lain-lain nga color nga nakita nimo dira isa ra gyud na siya ka mineral. And again, boring kay nga facts, sir, kabalo na may ana, sir. Of course, kay na-discuss man nato ang colors, no? Corundum na siya sa tanan, but then I also am thinking na maybe for the next, before ta mag face to face balik, ipakita na to gyud ta katag sa ang unsay tawag ana, nawong ni Ruby structure ba katong using Vesta ang, or pwede po mo kamo na malantaw daan structure sa Ruby, unsa ganing blue, aquamarine ba na siya, di ko kabaloon sana siya. So kana imong ruby and the rest kanang tulo ka buok na variation and color just from the mineral corundum. Let's try to look into the lattice niya nga arrangement ug lantaw na to kinsay naa sa iya ang tunga-tunga or color center niya nganong ingon ana iyang color. Okay, so when your mineral corundum contains a sufficient quantity of chromium, it exhibits a brilliant red color. So si chromium pwede gyapon siya makahatag og red nga color. And the gem now is called a ruby. So matawag nimo siya gem class kung gi-process na siya. So kung katong raw pa gani niya nga form, bahala pa nagpula na siya sa yung raw nga form, just like what you are seeing here. That is still corundum, but once it's already it underwent a process na imuha gid siyang gi-cut nimo siya, gi-polish nimo siya, that is now considered as a gem nimo karon, just like what you are seeing here. If a specimen is not suitable as a gem, it simply goes by its mineral name. So matawag lang gyud mo siya gem when it underwent a specific process and it now exhibit, kung malantawan nimo diri no, ang iyang luster kay near adamantine, mura na siya diamond og luster. Pero unsa man gyud ni siya, is it really adamantine? Marag duol na kay siya sa adamantine nga luster, no? Mura man siya diamond in appearance. Mura pud siya vitreous ang iya ang luster. So, as I've said, we will try to look into the lattice structure of this mineral corundum, why it is having different colors unsay naa sa iyang color center di ay. And for the next discussion, we are going to jump now into rocks na material of solid earth. So basically, dapat nakasabot ta sa katong kuan class. I think this is where I will end para dili ra pud kayo taas inyong online nga session. Ang inyong rocks, which are again the thing that we are going to discuss, na ana siya i-discuss na to ang rock cycle, pero I really want nga dapat nakasabot gid mo sa minerals before, kay para dali kayo sabton ang pag-abot nato sa rocks, nganong some of the rocks will tend to have white nga mga colors, nganong some of the rocks nga mga itumon man na sila. So kana siya, those are the things that we are going to discuss later. And also ang isa ka pinakakuan ani class kay, just by looking at a sample just like this one, sample of an igneous rock, kay maka-trace na mo, makahimo mog story sa iya ang hala, kini nga sample kay sure jud ko or dako kay chance nga na form gid ni siya sa ilalom sa earth kay ingon ani man iyang nawong. So isa na siya ka expected nga kaya ninyo buhaton after human nato ni nga discussion. But then again, maglisod mag-appreciate sa discussion kung wala kayo nasabtan ang discussion sa minerals. Because basically, your rocks kay made from your minerals. So, ang building block sa inyong rocks kay mga minerals sa gyud gihapon. So, that is why dapat nakasamot gyud mag-ayos sa discussion sa minerals. Okay? So, this is where we will end our discussion for today for the online class. And I am expecting that you will all take the quizzes. So it's not recorded, but then it's just to measure for yourself to gauge kung nakasabot pa gid mo sa discussion. Maybe I will just prepare maybe 5 to 10 questions. Then we have specific lang din nga time limit. So that's it for today, and I will be seeing you on Friday. So on Friday we will have what's this? We will have the continuation of our quiz for Omega, and for Phi, we will start with our quiz. And then after the quiz, dili man na mahuman nato ang time, we will start with our discussion on the igneous nga rock nato. So that's it, and see you on Friday.